Alright, welcome everyone. Let's learn how to parallel circuits. Dun dun dun. If you want somebody a little more predictable, this is not your channel. Here are the timestamps. Feel free to skip around. So, the reason I made this video is I notice a lot of my students don't always know when they are in the parallel section of a circuit and when they aren't. So, I made this video to, I don't know, give you something to work with, like a chance to win. At the end of this video, my aim is to make sure you know how to do, when to do our parallel, and when to do just regular adding resistors together like a robot. Ta-da! So here are some rules. Now I want to be clear here. I made these up, okay? I made these up so that you guys have some kind of GPS or something to just guide you through difficult questions. The first rule is there will be no current through a voltmeter. That's not fully true, but for the purposes of grade 11 and grade 12, it is true. No current through a voltmeter. The second rule that I made up is when the conducting wires split from each other. That is usually the beginning of the parallel section. I'll show you what it means in a diagram just now. The third rule is when the conducting wires join together again, that is the end of the parallel section. And again, I'll show you in a diagram. And then always, because this is science, there are the exceptions, the ones who don't follow the rules. So let's get into it, shall we? Here is our first circuit. This one is from the matric paper, November 2022. Setting the scene. You are busy writing a past paper, or you're practicing a past paper, and you're looking at this and you're like, where's the parallel section? I can't find it. Easy peasy. Okay, no, it's not always easy peasy, but this one is. What you do is you grab your pencil and you find the battery on your diagram. And it doesn't matter what end of the battery you pick. I'm just going to pick the bottom one because why? Because I feel like it. Now we drag our pencil along the conducting wire until we get to a point where it splits. Now, we look at what happens up in the split. Let's see. It ends in a voltmeter, and we said the rule number 1 is no current through a voltmeter. Alright, so the current does not go down there. It goes follow. It hits a resistor, no problem. It travels through it, keeps going, and it hits a split. Here, we check down there. There's no voltmeter, so yes, the guy will go that way, or the current will flow that way, and the current will continue forward as well. It gets to another split. If we go and check what happens in that split, voltmeter, no current through a voltmeter. Yes, and now we travel on. So this section here is the start of the parallel. And then here it travels along through resistors, through the switch. It hits another section over here, but it just goes back to the voltmeter. No current through a voltmeter. Yay! We come together over here. And here is the end of the parallel section. Alright, then we travel through an ammeter. Voltmeter again, none of that business, and back in the battery. So, from this section over here to that section over there, all of that is in parallel. How would you calculate this? It would look like this. 1 over r parallel equals 1 over, this is our first branch of the parallel section, 1 plus 1 over, and this branch has 2 resistors in it, So it's 2 plus 3. That would give us 1 over 1 plus 1 over 5. Which gives us 6 over 5. Oh man, I hope I'm not screwing this up. And therefore our parallel equals 5 over 6 ohms. Like a badass. Let me just double check my calculations. Yep, nailed it. Okay, moving on. I really encourage you to pause and try for yourself. Our brains thrive. They learn so well from small, bite-sized mistakes. Here we go. A slightly more confusing circuit, but let's do this. You find your battery. You choose a side, doesn't matter which one. Let's go up this time, just to be contrary. And we move up. We hit a fork in the road. Down there is our voltmeter. No current through a voltmeter. Yay. And we start traveling along. We hit a resistor, no problem. The current goes straight through a resistor. And we hit a split. Here we split up. This is probably the start of a parallel section. Alright, so we travel along. This one goes down all the way. That one. Another split, but no current through a voltmeter. Die. And here's another seeming, this looks like a split, but no. Push. That goes. And here we come together again. So here's the start. Here is the end. And we carry on through an ammeter. We can go through an ammeter, by the way. If this was closed, our current would move on. Oops, split again, but no current through a voltmeter. We're done! So, let's just see what that will look like. Our first branch of the parallel section is 1 over R parallel equals 1 over 6 ohms. And then the second branch has this business and that business, and that gives us 1 over 2.4 plus 6. Okay, this one I will not be able to do in my head. I want to blame it on because it's so late, but to be honest, I would struggle with this one any time of day. 1 over 8.4 gives me 2 over 7. Which gives us 3.5 ohm. So let's double check that. Wham. Skadoosh. Yep. Alright. Alright. So this one is just plain weird. Yeah. See what you get. Alright, here we go. Here's our battery, so I pick my spot and I start traveling. We get to our first split and we just check. It's like, okay, I don't see, this is not a voltmeter, this is an ammeter. Lots of current can go through an ammeter. We travel along, everything seems hunky-dory. Let's continue up. Here we split up, and here we can see we hit our voltmeter. Nope. So our current's going to continue down, and through. And the same over here. Okay. And they continue. There's nowhere to split. They turn back. Same over here. Wham. And wham. Okay, and here they rejoin. So over here, it's the end. And over here is the start. Alright, and then just to complete the circuit, bam, back in the battery. So, what do we learn? R parallel in this case would be 1 over R parallel, bam, bam. The first branch has 2 ohms, so it's 1 over 2 plus second branch has 4 and 8, is 1 over 4 plus 8. So that's 1 over, and 1 over 12. So would be 6 over 12, 7 over 12, 7 over 12, 12 over 7, and I have no idea what that is in fractions. It's our parallel. Bam! Bob's your uncle. Or maybe George, or I don't know. Anyway, how did you do? Did you get it? Did it get you? Alright. Okay, peeps. Now we're getting into the rule breaker sections. The first one is not that bad. It's actually doable. Alright, so let's see if we can do that. I have to admit, it looks bad. Like, if you're looking at this and your heart rate went up, it's like, that's fair. I'm not gonna argue with you. We find our battery, we start traveling, we hit our first point, it's like, okay, no current through voltmeter. And we continue on. And up, ooh, just a little wild over here this time. Okay, here we split up. I don't see any voltmeters, so we just go boink, boink. And this one, the current can go through an ammeter, so just don't let that stop you. Bam. And we're going to join up here again. Okay, so here we meet a parallel section inside a parallel section. It's like, what the even? What are we supposed to do? So what you do, let's mark this in a different color. No. Let's make it nice and different. So here, our current splits and rejoins and wham and zoom. So this is its own mini parallel section, and for this section we can do 1 over r parallel equals 1 over 8 plus 1 over 16. That would equal to 3 over 16. I really should check my work here. This one would be r parallel equals 16 over 3, and that would be 5.33 r. That was that parallel section. Let me just get my colors again. There we go. Straight through all of those, and here we rejoin. This is our end. And then our circuit doesn't actually split up again because we hit this section, but no current through a voltmeter. Back in the battery. So you might wonder, what does this, how do we calculate the resistance here? It would simply be 1 over r parallel equals 1 over r, which we don't know, plus 1 over that 5.33 plus 20. And now, unfortunately, we can't complete this question because we have 2 unknowns. Oh, by the way, this is the November 2015. This last one, I'm not gonna lie, I've been thinking about how on earth do I explain this one to you, because my rules don't quite hold the way that I would like them to. They'll get you there 95% of the time. So let's see if we can figure out the other 5%. So I thought long and hard about how to explain this to you guys, or if I could make another rule, and I couldn't come up with anything. But I do want you to be prepared for the next exam, so I'm just going to show you what I do. And if you have any questions, just ask them in the comments, and maybe that leads to a better explanation for all of us. Anyway, you find your battery. You start there, and luckily for us, there are no voltmeters this time. We get to a split, everything's hunky-dory, but here comes the problem. We hit a second split, and it's like, but why? Why you do that? Okay, basically, what you have to learn is that when you have a circuit that splits in this way, this is basically the same as a circuit that does this. Alright, so this kind of parallel setup is exactly the same as this parallel setup. Alright, Anyway, let me just make some space for the rest of my drawing. This continues through the globe, through the light, through it, bam, join, join. Basically, if I were to redraw this circuit, I would do it like this. Bam. Bam. These look like hot crust buns. I love a good hot crust bun. Like, man, those things are good, especially if they're like fresh and still warm and just yum, 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 yum. Anyway, here we go. That's what the circuit would look like, and they didn't give us the resistance here. But if you wanted to, it would be 1 over R parallel equals 1 over R of whatever the resistance of A is, plus 1 over resistance of B, plus 1 over the resistance of C. Don't use watts for this. Don't do that. Just don't. Okay. Any questions, hit me up in the comments, and good luck with your studying.